We will be ending today's webcast before payload deploy just after booster landing. At T-minus 7 minutes 30 seconds, we are looking good for an on-time liftoff today. Falcon 9 is healthy, the range is ready to support, and the weather is looking great with less than a 5% chance of launch constraints. While we wait, let's meet the vehicle that will take the TD7 spacecraft into orbit today. The Falcon 9 rocket you see on your screen is a two-stage vehicle standing 229 feet tall. When fully fueled, it will hold just over 1 million pounds of propellant, which we began loading at T-minus 35 minutes.
Engines are trailing in for flight.
And as you heard there, we are beginning thermal conditioning of the engines on the first stage of the vehicle. But starting from the top of our vehicle, the TD7 payload is safely enclosed inside the 17-foot diameter payload fairing, which is the nose of the rocket. Made of a carbon composite material, the fairing protects the satellite on its way to orbit. The fairing itself is actually two halves, both of which will be jettisoned about 3 minutes into the flight. The fairing halves supporting today's mission are flight-proven, with one half flying for its 20th time and the other for its 10th. Both fairing halves will be recovered after today's flight by our fairing recovery ship, Doug. Below the payload
Stage 1, RP1 load complete.
And there you hear Stage 1 kerosene load is complete. And below the payload fairing on your screen is our second stage, which is the part of the rocket that will take our payload to its destination orbit today. The second stage will ignite its single Merlin vacuum engine, or MVAC for short, about 2.5 minutes into flight, and then relight for a second time today before we deploy the TD7 payload. Below the second stage, you can see the black interstage, which is actually part of the first stage booster. At the bottom of that first stage booster are the 9 Merlin 1D engines that we just began conditioning for flight. And the first stage booster and its engines will help get Falcon 9 off the ground and into the thinner parts of Earth's atmosphere. Shortly after liftoff, the first and second stages will separate from one another, with the second stage continuing on to orbit while the first stage begins to make its way back to Earth. Now, our first stages are designed to be reflown with minimal refurbishment between flights, and today's booster is flying for its 16th time. We will be attempting to land the booster on our drone ship, a Shortfall of Gravitas, stationed in the Atlantic Ocean. And if we are successful in recovering the booster, it will mark our 369th successful recovery of an orbital-class rocket.
Tanks are pressing for strongback retract.
And as you hear Falcon 9's tanks pressing for the start of strongback retract, last but not least is the large truss structure that you see next to the rocket, which is our transporter erector, or strongback. Now, we use this to both roll the rocket out to the pad and raise it to the vertical launch position. The TE also routes the vehicle's fluids, power, and telemetry umbilicals up from the ground systems to the rocket and satellite up until the moment that Falcon 9 transitions to internal power.
Strongback retract has started.
And you can hear that call that the retract sequence for the strongback has begun. At T-minus 4 minutes 20 seconds, away from liftoff from Launch Complex 39A at the Kennedy Space Center, all systems continue to look good for a liftoff today. Now, at liftoff, the strongback will retract rapidly from Falcon 9, and in order to prepare for that retraction, we will shortly see the clamps around the second stage. And there you can see those clamps around the second stage opening, and shortly the TE will pull back just a few degrees to its pre-liftoff position. And you can see the light from the setting sun hitting Falcon 9 there as we head toward a liftoff at sunset from 39A in Florida. Now, at this point in the countdown, both the first and second stages are almost fully loaded with 1 million pounds of liquid kerosene and liquid oxygen. The first and second stages will finish loading propellant about a minute apart from one another, with the first stage wrapping up at T-minus 3 minutes and the second stage following at T-minus 1 minute. And there you can see the strongback has partially retracted away from Falcon 9. Now, some of the white clouds that you see around the vehicle there are caused as the chilled gas from above the liquid oxygen tank surface vents overboard to maintain pressure on the vehicle as we continue to load propellant. When that gas comes into contact with the warmer...
Load complete.
And there you hear that the liquid oxygen loading on stage 1 is complete. That white gas that you see there, when it hits the warmer atmosphere, condenses the water into the air, forming the clouds that you see. Now, coming up at T-minus 60 seconds, Falcon 9 will be in startup. This means that the rocket's autonomous internal flight computers have taken control of the launch countdown. Just inside of T-minus 2 seconds, we will light the Merlin 1D engines for liftoff. At this time, the payload continues to be healthy, and the Falcon 9 teams are working no issues on the rocket. At T-minus 2 minutes to liftoff, let's listen in and hear those series of callouts that lead up to launch.
Stage 2, LOX load complete.
And there you hear confirmation that liquid oxygen loading onto stage 2 is complete. This actually wraps up fueling of Falcon 9 for launch today. And you can also see that our final vent purge has begun on the transporter erector, those white clouds billowing out.
Ground gas closeups.
And that call also indicating that the ground systems are being configured for liftoff today. You can also see the water from the water tank, the water tower there that provides the sound suppression system for Falcon
9 in startup.
And Falcon 9 is in startup and has taken control of the countdown. The first and second stages are also pressurizing for flight.
Go for launch.
And there you hear our launch director giving the final go for launch call. So at T-minus 37 seconds, let's sit back and watch Falcon 9 take the TD7 satellite to orbit.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go Falcon, go TD7. Vehicle is pitching downrange. M1D chamber pressures are nominal.
And 35 seconds into the flight, Falcon 9 has successfully lifted off from Launch Complex 39A at the Kennedy Space Center, carrying the TD7 satellite. Now, during ascent, we tilt or gimbal. There you hear a call out that power and telemetry is nominal so far. Now, right now, Falcon 9 is gimbaling its engines, or tilting the engines so that the rocket will begin to turn horizontally in a maneuver called the gravity turn.
Supersonic.
Moments ago, we throttled down the engines in preparation for max Q, or the moment of maximum aerodynamic pressure.
Max Q.
And there you hear that call out for max Q, a critical moment during flight when the combined stresses caused by Falcon 9 accelerating through the atmosphere and the ambient static pressure are at their greatest. Now, right now, you can see Falcon 9 traveling just about 2,500 kilometers per hour. We are looking for approximately 27,000 kilometers per hour, or 17,500 miles per hour for our orbital velocity today. And you can track the progress to orbit by keeping an eye on the Stage 1 telemetry in the bottom left-hand corner of your screen. Now, coming up shortly, we have several events that will happen in quick succession, including main engine cutoff, or MECO, stage separation, second engine start 1, or SES1, and fairing separation. During main engine cutoff, we will shut down the 9 Merlin 1D engines, followed by stage separation. Once separated from the second stage, the booster will begin heading back to Earth while the second stage MVAC engine will simultaneously ignite for the first time, followed by fairing separation.
MECO.
Stage separation confirmed.
MVAC ignition.
And there you heard and hopefully saw a good MECO stage separation and ignition of the MVAC engine on stage 2. You can now see the first stage beginning its maneuvers to prepare for landing on the A Short Fall of Gravitas drone ship in the Atlantic Ocean. As a reminder, we will not have any stage 2 views today, but you can keep an eye on stage 2's progress with its telemetry in the bottom right-hand corner of your screen.
Fairing separation confirmed.
And there you hear confirmation of separation of our payload fairings. Having done their job, they will now parachute down into the Atlantic Ocean, where we will be attempting to retrieve them using our fairing recovery vessel, Doug.
Both vehicles are on a nominal trajectory.
And a good call out there that both Stage 1 and Stage 2 are following their planned trajectories. Just over 4 minutes into the flight, coming up at 6 minutes 15 seconds into the flight, we can expect to have some great views of the first stage's entry burn. Now for this entry burn, we will relight 3 of the Falcon 9 first stage engines on the first stage, starting with the center E9 engine, followed by the E1 and E5 engines. This will help slow the vehicle down as it passes back into Earth's denser lower atmosphere. And we need to slow down in order to reduce re-entry forces, which ultimately helps us recover and reuse the first stages of Falcon 9. And again, watching these views from the first stage, as the sunlight is hitting it in the upper atmosphere, you can see some of the ice particles coming off of the first stage, which is perfectly normal. Those flashes that you also see are the thrusters on Falcon 9's first stage, aligning it for the upcoming entry burn. And speaking of that entry burn, when that happens, Falcon 9 will actually be decelerating by firing its Merlin engines and flying through its exhaust or plume. This causes a deposit of soot to be This causes a layer of soot to be deposited on the vehicle's surface, which is why our flight-proven vehicles look the way that they do. That soot actually comes from the carbon-based fuel that Falcon 9 uses.
Both vehicles continue to follow a nominal trajectory.
Stage 1, entry burn startup.
And there we can see a good start to our entry burn.
Stage 1 FTS is saved.
This is roughly a 30-second burn, and you can keep an eye on how our speed is decreasing on the bottom left-hand side of your screen.
Stage 1, entry burn shutdown.
And we have had confirmation of entry burn shutdown. Now, reusability is key to lowering the cost of spaceflight, which enables more investment in critical scientific research. And the Falcon 9 first stage supporting today's mission has just performed its 16th entry burn and is about to perform its 16th landing. The Merlin engines that the first stage uses are optimized for sea level, producing about 190,000 pounds of thrust during ascent and descent. The MVAC engine on the
Stage 2 is in terminal guidance.
The MVAC engine on the second stage is actually optimized to fire in the vacuum of space, producing about 220,500 pounds of thrust. Coming up next will be the first stage landing burn, and as a reminder, we are targeting
Stage 1 transonic.
We are targeting landing on our drone ship, a shortfall of gravitas.
Stage 2 FTS is saved.
Also continuing to hear the callouts for flight termination system safing on stage 2, a nominal call.
Stage 1 landing burn.
Nominal park orbit insertion.
And you can see Falcon 9 performing its landing burn as we also had a good call for stage 2 entering its parking orbit.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
And there you have it, SpaceX's 369th landing and recovery of an orbital class rocket. Now, with our first stage safely on the drone ship, as we mentioned earlier, at our customer's request, we are going to be ending today's live coverage before payload deploy. So with that successful landing, we're going to wrap up our launch coverage today. We want to thank you all for joining us for our 212th successful launch of 2024. All of us here at SpaceX would like to thank our customer for entrusting us with today's mission, and we also want to give a special shout out to the Eastern Range and the Federal Aviation Administration for supporting today's launch. As always, thanks to our viewers for tuning in and for your continued support. Remember to follow us at SpaceX on X for launch updates, and if you're a launch fan, be sure to continue to follow along with us over the next 3 days as we launch vehicles from every single pad we have in Florida, Texas, and California.
And there you go. SpaceX has done the 16th launch of the Falcon 9. Thank you for watching. Please subscribe. See you next time.